specific axis, and to do that you're going to need three vectors. Firstly, the unit vector um, in black here. The unit vector about the hinge. So you're looking at this unit vector right here, and that's from the origin to point A. So unit from origin to A. You're going to see that the vector goes over 0.3 meters in the I direction. You can see that here, and then it goes over 0.4 meters in the J direction. To unit that, you go ahead and take this squared plus this squared. You take the square root of that, and you're going to get a unit vector of 0.5. So divide both terms by 0.5. Unit vector is going to be 0.6 in the I direction plus 0.4 divided by 0.5, 0.8 in the J direction. So now you have this unit vector. Now you need to find a vector which points anywhere along this axis. Think of that as like the hinge of the door. Anywhere from this hinge to anywhere on the force. So you could choose from here to here, from here to here, here to here. The simplest is to take the origin of the hinge here and find the vector that points to this point on the force. So that vector, our R vector, is going to be equal to 0.5 in the I direction plus 0.5 in the K direction. That's up the Z axis. And then finally, find your force vector. Your force vector, first you're going to find out this point here and then this point here, and you're going to subtract them and then find the unit vector. You're going to multiply that unit vector by 300. So we'll label this point B and this point C. So point B is going to be at 0.5, 0, 0.5. And then C is going to be at, you can see here it's at 0.1. It starts here in the X direction. It's going to be 0.4 in the Y direction and 0.3 in the K direction. So your force direction is going to be head minus tail. 0.5 minus 0.1 is 0.4. And then here you're going to get minus 0.4 and 0.2. Now you need to turn this into a unit vector. So there's two parts you have a unit vector of in this problem. First is your axes. You need to make a unit vector, and then you need to start out with this as a unit vector, and then you're going to multiply that by the force when you're done. So 0.4 squared time plus 0.4 squared plus 0.2 squared to the 0.5. Divide every term in here by 0.6. So your force as a unit vector is going to be equal to 0.4 divided by 0.6, or 2/3, and then minus 2/3, and then 0.2 divided by 0.6 is going to be 1/3. Now that you have your force vector as a unit, multiply that by the magnitude of the force to get the actual complete force vector. 2/3 times 300 is going to be equal to 200 minus 200 and 100. So now you have your three vectors. Along the hinge, you have your unit vector here. You have the vector pointing from the hinge to the force line. And this vector can take a lot of forms. It could point from here to here, from here to here, or from here to here. We chose the simplest one. And thirdly, you have your actual force vector. So moving along here, to solve this, what you'd want to do is create a determinant. The actual formula to solve this is your unit vector along the hinge from your origin to A multiplied by the cross product of R cross your force vector. What this is going to look like is a big old determinant right here. And so you have 0.30, 0.3, and then 0.40 is going to be your first row. 0.3, 0.40. So start with a hinge, point towards the force vector, and this is 0.5, 0, 0.5. And then finally, the force vector itself, 200, minus 200, and 100. And you take the determinant of that. So start out with your hinge, point from the hinge to the force vector, this row, and then finally you write the force vector right there. And take the determinant of that. So that is going to be 0.3 times 0 times 100 is 0, minus a minus 200 times 0.5, so you get a plus 100, plus, or rather minus 0.4, because this term, when you're taking the determinant, is minus, times 0.5 times 100, or 50, minus 0.5 times 100, which is minus 100. And moving on to the last term, plus 0 times, it doesn't matter because it's going to end up 0. So right here you have 0.3 times 100, 30 minus, there's going to be minus 0.4 times a minus 50, or 0.4 times a positive 50, 20 right here. In total, you're going to get 10 Newton meters of force about this axis. Alright, so that's pretty cut and dry. You just start getting the unit vector of your hinge, point from the hinge to the force vector, that's your second row, and then the force vector itself is the third row. And for this guy and this guy, you need to take the unit vectors, leave this guy, the hinge, as unit vector, but for the force vector, multiply the unit vector times the magnitude, and that's going to go in here. Thanks for watching.